Hello students, still your math teacher, Mr. Femi Lawal. I'm back to continue with the topic linear inequalities. In the last class, we treated word problem leading to inequalities. We also presented how we can represent an inequality, the graph of inequality in one variable. Now, we want to achieve the objective of plotting the graph of inequality in two variables. Yes, inequalities in two variables. Now, we remember that, under simultaneous equation, where we have two variables such as x and y, when we are plotting the graph, when we are using the graphical method, we need at least 2 points. At least 2 points are needed to get a straight line from each of the two or more equations under simultaneous method. Now, let me quickly explain the concept of the linear equation. The general form of the linear equation is y equal to mx plus c, where the y is the dependent variable and x is the independent variable. Looking at the coefficient of x here, which is m, the coefficient m represents the slope, otherwise known as gradient, and the c represents the y-intercept. So, if the general form of a linear equation is y equal to mx plus c, we can as well have the general form of a linear equation, of a linear inequality as y asterisk mx plus c, where the asterisk can be less than, greater than, less than or equal to, or greater than or equal to. Plotting the graph, we would need 2 points, at least 2 points. Generally, we use 2 points to plot a straight line of a linear inequality. And what do we need here? 2 correct points will give us a straight line. So we need the x-intercept and the y-intercept. What are we saying here? When you limit y to 0, when y is equal to 0, when y is 0, you have a value called x. Then when x is equal to 0, you have a value of y, which is c. Now, if you look at this statement here, assuming my y, the gradient is given, okay, let me just take this question, equal to 2x plus 7. At this point, if I'm to get the the y-intercept, I only need to say x is equal to 0. Just substitute 0 for x. So you have y equal to 2 into 0 plus 7. Definitely, my y-intercept is equal to 7, which means that I have 0, 7. If I'm to get the x-intercept from this, I only need to say my y is equal to 0 when y equal to 0. And that is giving us 0 equal to 2x plus 7. And that will be 2x equal to minus 7. When you divide through, you have your x equal to minus 3.5 here. And that shows that you have x-intercept, which will be negative 3.5, 0. And that's all you need to do. The two will give you a straight line. These two will give you a straight line. So you only need to take it to the Cartesian plane and represent it, and from there you have a straight line. So, taking these 3 examples, and we are going to plot them. I'm going to show how you can represent this on your Cartesian plane. So all you need to do is to get a graph sheet and represent it, and you see the beauty of the inequalities. Like I've mentioned earlier, you'd use bold line, which is a solid, to represent greater than or equal to, less than or equal to, and you also use the broken line to represent greater than or less than. Now I classify them as exclusion and inclusion. Exclusion, less than, greater than. Inclusion, less than or equal to, greater than or equal to. Now let's run these three questions, examples quickly. Given y less than or equal to 3x minus 6, I am not going to work with this sign for now. I'm going to suspend it. So let y be equal to 3x minus 6. By the time I get the two coordinate points to plot the straight line, then I can now come back to the original inequalities to determine the area to be shaded, which will be the required region that satisfies this inequality. Now, I'm going to solve this to get two coordinate points, the x1, y1, x2, y2. Get the first one. When x is equal to 0, definitely we are looking for the y-intercept. So you have y equal to 3 into 0 minus 6. And my result is what? Minus 6. Therefore, I have x, the result to be written in the form of x comma y, which will be 0 comma minus 6. This is the first coordinate point. Then I'll go again to do the second one. When y is equal to 0, then you have 0 equal to 3x minus 6, and that is 3x equal to 6. Divide through by 3, your x will be equal to 2. So I have the second coordinate point, which is 2, 0. So these two coordinate points will give me a straight line. Now let's represent this on the Cartesian plane. We have the y and the x axis, the y vertical and the x horizontal, and the center where the two lines meet, the point of intersection is called the origin. Now, I'm going to represent the first one, 0, minus 6. 0, minus 6. When x is 0, that is the meaning. This is the x line. When x is 0, y is negative 6. From this origin downwards is negative x y axis. Then it says when x is 0, y is minus 6. Let me label this minus 1, minus 2, minus 3, 5. So when x is 0 here, y is negative 6. Trace it down. I have the first point. Go again. When x is 2, y is 0. So let me label this 1, 2, 3, and so on. When x is 2, y is 0. So trace it to 2 on x axis. Then I'm going to join these points together. Then I'm coming back to the original inequality, which states that y is less than or equal to the right hand side. Now, why do I need this? If this is exclusion, less than, you need a broken line. But because it is inclusion, less than or equal to, you need a bold that is a solid line. So I'm going to point this carefully through the center. Don't stop at the 2 points. Let it be extended. So at this point, the two coordinate points, the x-intercept point and the y-intercept point, I've joined them together. The next thing I'm going to do, you observe here that this line has divided the coordinates, the Cartesian plane into two. You have one on this side, the other here. Now, to determine which side is the required region, that is the region that satisfies the inequalities, I simply do this. Look at my equation. I have y less than or equal to. So with that, I will go to the y, where the y-intercept point, which is -6 here. This side this way means, if you let's look at it. After this 6 and -6, you have -5, -4, which means that they are greater. But when you come down, -7 is actually less than -6. Shade this inequality. The region that is required. Now, the way I want to do it is to shade off the region that is required. It is still possible for you to shade off the region that is not required, then indicate with capital R that the region which is not shaded is the required region. But for the purpose of understanding, I want us to start by shading off the region that is required. Don't get confused. You will see in other books shading off the non-required region and indicating capital R. It is still acceptable. So, since y is the subject here now, y is on the left-hand side, the subject of the formula here, then it shows I want to look at it with this division. Y less than or equal to, the numbers above 6 here, this is the y, and on 6, -6, numbers above are greater, and the numbers below here are less than. That shows that the required region is on the right-hand side. So I've shaded off, since I'm shading off the required region. Shade it this way. This is the way we shade it. And that is done. Then the next thing you will not forget to do is to write the inequality on the line, 3x minus 6. And that settles it. Yes, I'm taking the third question. I have 2y minus x greater than -7. So I'm not going to solve it this way. I'll say let 2y minus x be equal to -7. So whichever way I want to run it now, I can make either x or y subject of the formula to make the work very easy for me. So if I'm making y subject of the formula, I have x minus 7 divided by 2, and y is equal to x minus 7 over 2. So when x is equal to 0, I still need to get the two intercepts, x and y intercepts. So when x is equal to 0, you have y equal to 0 minus 7 over 2, which is -3.5. And that gives us what you have in x comma y, 0 comma minus 3.5. That's 3.5. Again, when y is equal to 0, you have 0 equal to x minus 7 over 2. And that will give me x. When you clear this fraction, you have x equal to 7. X equals to 7. So put it in x comma y form. You have 7 comma 0. 7 comma 0. So, and these two coordinate points as well, the x and y intercept will also give you a straight line. We also give you a straight line. Let's go to the Cartesian plane. This is not drawn to scale, just to explain what you need to do. Now, the first one says when x is 0, the center is 0, y is minus 3.5. Y is minus 3.5, so you are going below 0. Minus 1, minus 2, minus 3, minus 4, and so on. So minus 3.5 should be about here, between minus 3 and minus 4. That is when x is equal to 0, y is minus 3.5. Then the second coordinate point is saying 7, 0, which means when x is 7, y is 0. 1, 2, 3, 4, 5, 6, 7. This is my y-axis, x-axis. So you have when x is 7, y is 0. So I still have it here. So the next thing I will do is to join the 2 points together. But before I go ahead, I need to go back to the statement, the inequality statement. It says greater than, which shows that it is exclusion, excluding the number in question. So what are we doing here? If it is inclusion, you use solid line, but if it is exclusion, you use broken line. So I'm going to plot this that same way. Make sure it is carefully done, make sure it's at the center, and make sure you extend it beyond the 2 points. So I have solid, I'm making it broken line. Okay, I have a nice broken line here, which represents exclusion. What that is telling us is that the number, any number on this broken line is not included. But when it is bold, it is solid, every number on that line is included. That is the meaning of the inclusion and the meaning of the exclusion. So this way, let's come back to the original equation. I will make x or y subject of the formula. Use the one you prefer. So I think I want to use y again, or I should use x. Let me use y first. Y is greater than, according to what I have here, I'm moving x across, so you have x minus 7 divided by 2. Yes, I have successfully converted this equation. I'm making y subject of the formula. I'm using that because it is the standard for equation of straight line. The left hand side is always y. Now, if this is a straight line and the statement is saying y greater, yes, greater and not equal, then I have a broken line. Greater, where do I have y greater? Y greater. Every number above minus 3.5 is greater than the other side. So you have this side as greater, and shading off the required region. Like I said earlier, you can still shade off the non-required region and indicate capital R as required region, but I'm doing this is what I want. You choose what you want to use. This arrow indicates that it continues, does not stop here. Okay, so that way. And before you stop, make sure you write the equation on that line. I'm putting it here. 2y minus x greater than minus 7. That is the region required. I want. You choose what you want to use. This arrow indicates that it continues, does not stop here. Okay, so that way. And before you stop, make sure you write the equation on that line. I'm putting it here. 2y minus x greater than minus 7. That is the region required. So this is where we're going to end today's session, and we have assignment number 3. You have to draw the graph of each of the following. There are 3 inequalities, and make sure you use a graph sheet. Draw each on a Cartesian plane page, please. Don't use a plain paper. And scan and forward to the email fgcphDGclass@gmail.com. Remember to indicate your name, your class, the subject, and the topic. Thank you. God bless you. See you again.